y equals brackets x plus 1, bracket x minus 2 times bracket 3 minus x. So let's have a go at this one then. So you can see that when you expand this bracket in your mind's eye, the x times x times x will come out as an x cubed term, won't it? And it'll be minus, because there's a plus here, and a minus there. That will give a minus x cubed. So as x gets large then, approaches infinity, because it's minus x cubed is the dominant term for large values of x. And it's minus something x cubed. It'll be minus infinity cubed. Minus times a minus is, well, minus rather, of something cubed is a minus. And as x tends to minus infinity, y will tend to, well, you'll have a minus at the front, but there'll be a minus cubed as well. So there'll be 4 minuses, which will make a plus, won't it? So it will shoot off to plus infinity. So as x gets large, it goes down. It's going to come up. And as x gets large negative, it's going to tend to infinity up here. So it's going to come down, turn, go back down, up, and turn and go back down. That's a typical cubic curve, isn't it? When it looks like that. The roots are at minus 1. So there's here, the roots are x equals minus 1. When x is minus 1, this will be 0, so y will be 0. When x is 2, and also when x is 3, isn't it? We can see those. So minus 1, 2, and 3. So it's going to come up through 3, back down through 2, and then go down and come up through minus 1. And the value when x is 0, we can see what that is. Put 0 in for x here, here, and here. And we'll get 1 times 3 is 3, times minus 2 is minus 6. So I'll try and sketch it then. It's going to come up at 3, and go back down at 2, and come back up at minus 1. So this point was minus 1, this point was 2, and this point was 3. And this value here, we said when x was 0, we had the value minus 6, wasn't it? Times 1 is minus 6. Label the curve then. Y equals x plus 1, x minus 2, and 3 minus x. Let's put it in the plotter just to check that we're on the right track here. So we want to type in here x plus 1, close bracket, x minus 2, and then we want 3 minus x, isn't it? So let's put that in, and type it in correctly helps, of course, like so. We'll go from minus 2, just below the minus 1. The biggest root is 3, so if we just go past that to 4, say, and we'll have a look at the curve, see if we've got it about right. There we go. It swings down through minus 1 as a root, goes to minus 6 when x is 0, comes back up, goes through 2 as a root, back through 3 and back down. Shoots down to minus infinity as x gets larger. You'll see there's turning points here. We weren't asked to find them, but if we were asked to find them, we would expand the bracket, differentiate, and find the turning points here and here. Okay, good.